The following is intended for informational purposes only. It is intended to supplement classroom training and documentation. It should not be relied on as a replacement or substitute for classroom training with a live expert instructor. This workshop uses ProcessFlow to create a custom registration form. This example registration form is for training purposes only. In no way does it replace the existing base registration form. Lesson 15, Query Zones, where will we be looking at customizing the query zone in the registration form, and we will be looking at techniques to deal with CLOB data, showing CLOB data as output from a query, and also querying by CLOB data and how one can do that. We will also be looking at info algorithms and how you can customize them, and how you can have a hierarchy of info algorithms, starting from the maintenance object to the parent BO down to the child BO. And again, we will be concentrating on our registration form and looking at our example of dealing with the registration form name, which is the data which is in the CLOB, and being able to show that registration form name in a query result, and also querying by that registration form name itself. ProcessFlow query. The ProcessFlow query has 6 queries underneath it. In fact, this zone is a multi-query zone which calls underneath it 6 subzones, and we have a query by person name and process ID and many others, account, tax, role, and obligation. The first change that we have made on our registration form query was to get rid of some of those, so that we only have query by the process flow, which I called registration form here, and person name, which is we had which are the original ones, and we've added another one in, query by the registration name. All the other ones we have removed, account, tax, role, and obligation, because we don't use them within the registration forms. A query which I do on the process flow search of DILL, for example, brings up all different process flows, including registration forms and also hardship. And you'll see again that hardship uses account, tax, role, and obligation, but as you see, the other two do not. So that is the query when you do that within the process flows query. But if I do that within registration form, you will see that I only show the registration forms, and I don't show the hardship process flow type. So that's one of the changes that we made. You also see that we have renamed some of the columns, registration form info instead of process flow info. I have removed some of the columns that we are not interested in, account, tax, role, obligation. I've also changed the info string. These are the info strings. The standard info string, which was used for process flow, gives the process flow type and then the creation date. What I've done for registration form is to add in the status, and for individual registration form we've also acted in the ID value. The purpose of doing that was just to show that you can customize the string by the different types of BO, and we'll investigate how you do that. Okay, so the first thing I would like to look at is the query that I changed in order that I do not show anything but registration form. So let us use this opportunity to go into this zone, CMRGFGAQ2, and look at that. If I go to the zone here, I'm running under debug mode, so I can see, go directly to the zones. As I said, this is a multi-query zone, and here you specify the zones, and this is the one I want to look at. This is the subzone now that I'm looking at. So let me point out some of the important parameters within these zones. As you will see, there are actually many different parameters possible, because you can actually create multiple SQL statements. You can make up to 8, 9, 10 SQL statements. Generally, we only use one, and then there are many other parameters. So I'm going to just point out the ones that we're using. First of all, here we define the actual label which comes up when we actually do the search. So it's equivalent of this particular label over here, person name. Here we have what is called a validate filter service script, where you could actually put in a script which determines what will happen if you do not fill in the form correctly. For example, again, I'm switching here, by the way, looking at the zone and looking at the process flow query. For this purpose, I can use the process flow search. It's equivalent, or perhaps maybe since I'm looking at this specific one, why don't we move over to the registration form? So let's say if I actually search without putting person name in, I come up with this message. This is controlled by this service script over here. I can define the number of rows, maximum number of rows displayed, and over here I define how many and what columns are shown. If I put in something here, you will see that we have 5 columns, and it's these 5 columns, and these C2, C1, and so on correspond to column 1. It's this particular parameter here. So column 1, if I put C1 at the top, which I have here is number 3, that is defined in here. So you will see that most of the columns have source saying SQL, and it means that it's taking the data directly from the SQL statement, and we'll look at that in a moment. Some of them, like foreign key ref, define in this case, it's the info stream, because the foreign key ref has an info directly related to it, and so actually you don't always have to directly take SQL information. For example, over here I have an input coming through saying process flow ID equals process flow. It's coming from the query as an input, and then it picks up and works from the foreign key and shows the info string using the foreign key ref. We have another example at the bottom as well, which we'll look at soon, where the source is actually a service script. Anyway, so let's just look at the query itself, and you will see that the query is basically a relatively simple query based upon a condition where I'm searching on the name. The original query of the process flow, which this was based upon, is much longer and more complicated because it has these account, tax roll, and obligation columns, and in order to work with those, there's aspects of security that you need to test and to search for. So the query there is much longer. However, since I'm not dealing with that, I could simplify this query. I've also added in here an inner join. This inner join is what actually has done my work for me to minimize, to select only the registration forms. Now here I am showing only registration forms whose registration form type, which is in the process flow type, has a business object which is CM reg form type, which is the right way of doing it. And therefore I only show registration forms. So you need to know SQL, you need to be comfortable with inner and outer joins. You generally work together with an SQL client, which you can test the queries directly. Generally, I use Oracle SQL Developer, and you can check to see what the outputs are, and then you can make sure and test to see if they're working by putting the data in here. The important thing is to remember that the actual values, entered, F1 corresponds to, as you see over here, SQL1 condition is F1, and that's the input that I am putting in above. Okay, so in other words, when I do my filter, here is F1, so this is F1 over here, and I define that in my particular query here, I'm going to be using F1, and then I put F1 directly into the SQL over there, like that, with a colon. Okay. So again, I have changed and manipulated the base process flow by only showing specific columns, and I've also changed the underlying query. So that is the first change that I wanted to point out. The next one, which I wanted to show, is the one which I've just commented a moment ago about the fact that you sometimes can actually have an output not based directly on the SQL. Here I have a service script, and the way it works is that I can input to a service script from the output of the query. In this particular case, I'm outputting column C4, which is my process flow ID. I'm inputting into the service script CM get registration name, and I'm using service script, and what it will do over here is get for me the registration name. So where is the registration name? Let us familiarize ourselves with where the registration name data is found. So if we look at the business object, take the individual registration form, you remember that we added in the name, the first name and the last name, and the first name and last name is defined as CLOB data. And the point here is that even though it is very common and useful and easy to work with CLOB data within the context of business objects, when it comes to query zones don't work but on business objects. It works direct on the database. And therefore, to actually work with CLOB data, it's not as simple as working with a real field. Because of that, it isn't trivial to actually pick out the first name, last name, or in this case, I want to show on the output the registration name as first name space last name, because that data does not reside in a real field. So that's the reason why we use this service script. So the service script itself is called by as an output of the query. And let me just go now to that, and we will see how that service script works. So first of all, if you look at the schema takes the input as the process flow ID and sends out the registration name. And again, now looking at the step, what I basically am doing over here is something very trivial, calling the BO, passing in the process flow ID, getting the business name if it exists, and that is what will happen for a business registration form, and I'm just setting it as the registration name. And if it isn't a business registration form, an individual one, therefore, I take the first name, space, last name, and set that as the registration name. And that's basically what's happening when I do a query and I have, in this example, registration name Dylan Warehouse. It's taking the data from the BO, from the first name, last name, and creating that for me. In the case of the business, that is just in one field. In the individual, it's a concatenation of the first and last name. So that's different than, for example, the person name, where it's always the last name, comma, first name in the case of the individual. Therefore, when I actually do a query on the word, let's say, John, on the person name, I will not actually bring up anything because the person name starts with Dill. It's only when I do a query on the registration name, which is something now that we're going to now look at, then I will be able to see the, it will pick it up now. Since I created the first name, last name, registration name like that, therefore it picks it up. Now, how do I do a query on the registration name? We've just now spoken about how do I show the registration name as the output. That is done, as we just described, using this service script. But to do a query directly on a where clause to filter the registration forms by the registration name, that won't work in the same way. I actually have to affect the actual underlying query itself, because it's not something I can do after the fact. I can't query by everything and then process something to filter by. The filtering has to be done on the SQL. So the way I'm going to do this is by doing a little bit of a trick, and that is, instead of only holding the registration name in the CLOB data, I'm going to move the information to another real field. And that, where can I set the data in a real field? I can set it in on characteristic. Characteristic data in process flow characteristic, I can actually hold this information. So let me just show you what I mean. If I look at this particular registration form, let me just copy this, and I'm going to just show you the query directly over here. So I can do a query directly, and I want to do it this way just to show you the underlying table, process flow characteristic, and there you see that I have a characteristic type with the ad hoc value, and somehow I have set things up such that this characteristic is always added and updated whenever I change the registration name. How have I done that? Well, first of all, I've introduced a characteristic type called registration name in the system. So if I go to characteristic type, this is the registration form name that I'm using, and the way it's introduced into the business object is in the following way. So let me go to the I'll go via this way over here. I can go into the BO over here. If I go to the underlying parent BO, and I go to the data area, which holds the main section, and go to the schema, I've added in something called an entity name. And the entity name is an example of an element which is called a flattened element. I have flattened the characteristic value, even though it is in a child table, but I've flattened it as if onto the BO, as if it is actually an element just like any other element which is on the main table. And the way I do that is by filling in the data in the following way. I define the underlying table field that I'm using, which is the ad hoc value, which table that I'm using, the process flow characteristic, and I'm using where the characteristic type is equal to the one I just saw in a second ago, the registration entity name, and the sequence number, there's only one I set to 1. And if I look in the XML in the source view, you can see it as simpler in a way to see how it looks. Now, this is what has been added to the BO, and it's actually set so that I never see it, okay? Because it's going to be a hidden field. I've hidden it, but I'm going to be processing whenever I update or make a change to the registration form. I'm going to, and the name is changed. This is going to be updated as well. So in other words, I'm holding the name not only in the first name, last name, which is on the child, but also as an entity name on the parent, and the way I'm going to do that is by using a pre-processing algorithm. A pre-processing algorithm runs just before committing the data to any update to the database for any changes to the BO. And in this case, I am going to be doing exactly the same code that you saw a moment ago in the server script, which picks up the process flow ID and puts the first name, last names, and concatenates it. Here as well, I'm going to now be setting it on to the ad hoc characteristic value. And again, the reason why I have to do this is because I have to have the data of the underlying name somewhere in a real field in order that I can do a query. Okay, this is a little bit more complicated than when I actually need to do an output of the registration name. Of course, once I've actually done this and used the characteristic, I wouldn't actually need to use the server script that you saw just before to show the output of the registration name through the server script. But I just wanted to show you the different techniques, and sometimes you don't need to actually query by the CLOB data registration name. So the server script still has a value if you do not want to actually change the underlying BO, needing to actually add data into the characteristic tables. That's a lot more work, and sometimes you only need output and not query by filtering. So sometimes it's sufficient just to get away with using that server script technique. Anyway, where is this particular algorithm, the pre-processing algorithm? Well, let's see. I put one on. If I go to the algorithms, here I have this is the parent. I was meant to be on the child. And I've put this on the child because the first name, last name is actually on the child, and therefore it is easier to actually work with it on working as on the child as opposed to putting on the parent. If I have a look at the way it's done in a very similar way by just concatenating. And what I've done is, if you look at your parameters that we have in the request all the data of the parent and the child. So I have the entity name over here, which is on the parent, and I also have the child first name, last name here over here. Over first name, last name, and I've taken that data and populated it into the entity name. So actually, the explicit fields are all shown, and you don't actually have to query the BO itself in order to do this. And I have a similar one on the business registration form, and that one's simpler because I just take the business name and set it as the entity name. So that is the method that has been employed in order to set the registration name. And by the way, the entity name and registration name I've used interchangeably here. In order that I can ultimately filter the data by that registration name. Okay, so what have I had to do in order for this to work? I've had to actually set up a new characteristic type. I had to add a pre-processing script. And also the third thing is to actually change the underlying query. So let's go back and look at the query that we were looking at previously. Now this is actually not the right one. I want to now look at the registration name one, which I believe is got a 3 at the end. And if you see here, the query is similar to the one we had previously. However, I've added in this this another inner join. And this another inner join, what it's doing is basically bringing up the characteristic table, the process flow characteristic of a specific type, and doing an upper looking. It's not cap sensitive, so that I can actually query filter by the ad hoc characteristic value whatever I put into the filter value. So when I have the F1, which I put, if I go into here and I go, this is the query that we're dealing with, registration name. When I put in like this DA, and I'm picking up this query over here, that query, what it's doing is basically DA is now put in an upper ad hoc is like upper DA, and picks up everything that begins with DA in the registration name. Okay. So that is the method I have employed in order to do this query. One last thing I would like to look at, and that is the info strings. Info strings, as they appear over here, are defined by the foreign key. If I actually look at the zone, and I see over here in column source foreign key, this is the foreign key that I'm using in order to show the info string. So if I go to, let's use it over here, if I go to foreign key over here, this one over here. So foreign key defines a few important aspects. Some of them are related to navigation. Where does it actually navigate to afterwards? And we've actually seen this before, and I've actually pointed out that sometimes foreign key navigation options are overridden by the portal navigation options on the BO, and that's what we found. Because actually with registration form, we've never changed our foreign keys. I've never created a new foreign key reference for registration form, and it still has nav option set to process flow. But interesting, the portal nav option on the BO overrides this. So that's not always the one that is used. Similarly as well, info program name defines another aspect, and that is the actual info string. And this generic MO info retriever works in the following way. If you have a MO with an info program, and we'll look at an algorithm, it will use that algorithm. And for process flow, we will see now, if I go to the MO, maintenance object for process flow, you will see that it has an information algorithm. This information algorithm is responsible for showing that info string if and only if there is no underlying business object with its own information algorithm. If there is, that one will override the one here. Information algorithms are different than many other system events. Most system events work that you could have multiple system events of the same type running in a certain order from the parent to the child. In the case of information algorithms, only one can run, and the way it works is an MO is overridden by a business object, and if there's a parent-child, the child is overridden by the child. So I can actually show you what I mean by this by, first of all, going to the registration, not the registration, I'm going to actually go to process flow, and I'm going to put in what we put in before, and we have 3 process flow examples here coming up, 3 records. The one in the middle is the hardship, and this one is again just the type and the creation date. And the reason why that is so is this particular hardship BO does not have an information algorithm, and therefore the information algorithm which is used is the one on the MO, the one I'm clicking on now. And if I look at this particular one, this one uses the description and the creation date. However, in the case of the business registration form, it also shows the status, and the reason for that is because on the business registration form, if I go to it, not directly, but on its parent, it has an algorithm over here, information, and that's one which will be used. And this particular one will also add in the status. Okay, so I've created this particular algorithm, and at the bottom what I've done is I've concatenated the description, the creation date, and also the status. And the point is, if I go back now to the registration process flow query, which I just came from, the individual one also shows the ID value. And the reason for that is that the child individual registration form has its own information algorithm, which overrides the parent. And this particular one adds in, on top of the active on the status, adds in the ID value as well. And again, I'm only doing this in order to just show how this concept works. It's not a usual thing to show the ID value, but you get the idea of how the info strings work in the hierarchy. So what have we learned in this lesson? We have shown how you can output in a column CLOB data on a query zone. This we did by invoking a server script on the output of the query. We have also shown how you can create a query zone filtered by CLOB data, and that we did by adding in a flattened characteristic to the business object and querying by that characteristic. Finally, we moved on to look at information algorithms and how each one overrides each other. We see that a BO info overrides the MO, and the child overrides its parent. Can only have one, and only one is actually invoked, as opposed to other types of algorithms where both the parent and the child are activated. In this particular case, only one, and it is the child one which takes precedence over all the others.